Hello, I'm Logan Rohrbacher, and I have problem number 8 because of my last name being an R.
So, as you can see right here, part A says find the first partial derivatives of f of x and f of y. So right here, finding the first partial derivatives of f of x and f of y, we will start right here and only look for the x's with f of x. So that would make it 1/2 x squared plus 2x plus y, because that x would be equal to 1. And then right here, looking for the f of y, there is no y here, there is no y here, but there is a y here, so that would make it x minus y with that derivative. So as we go here, we are asked to find the critical points of these. So by doing that, we will actually be using our f of x and our f of y. And right here, we will set these equal to 0. And as we set x minus y equal to 0, x equals y. So right here, we will plug the x where this y is at and make it 1/2 x squared plus 2x plus x equals 0. Simplify that to 1/2 x squared plus 3x equals 0, and then you'll be factoring those out to make it 1/2 x, and then in parentheses times x plus 6 equals 0. And that would make our critical points -6, -6, and 0, 0. And then over here, when we are finding the second partial derivatives, we will be actually using these as well, and only using the x parts. So fxx would make that, once you factor that out, it'll make it equal to x plus 2. F of x of y would make it y equals 0, so that the derivative would also just be a 1. Fy of x purely would also be 1. Fy of y will be that -1 because of the negative right there. And then for the final part, when we are classifying all critical points according to the determinant test, put your final answers in the box, and then write none if there are no answers written in the box. So right here, we would have our formula of f of x times fy of y minus fx of y squared. And after that, we'd get -x minus 2 minus 1, -x minus 3. And then we would plug our critical points in there with the x. So that would be a -6 and a 0. As you can see, the 0 equals -3. And the -6 would become a +6 and would become 6 minus 3, which would equal 3. So that -3 is going to end up giving us a saddle point because of it being negative. So you can see that we have that saddle point at 0, 0. And then because of it being a positive, that would qualify it for the relative extrema, which means that we would have to plug it into here because there is the only one without the absolute value. So that we get -6 plus 2 equals -4, which shows that we would have a relative maximum at -6, -6, and not have a relative minimum. So that right there is my whole problem sheet.